Bismillahirrahmanirrahim. In this session, we will discuss some geometrical terms, some definitions. A point has no dimension. If a point, it has no dimension. A line has a length but no width. Line has a length but there is no width. It has only one dimension. That's why it has only length. It's in only one dimension, one direction and one dimension. This can extend up to infinity, but its width is zero. A plane has a length and a width but no height. So this is a plane. It has no height. It has a length and a width but has no height in a vertical direction. So a shape which has a length, width and height has three dimensions. So here we have a length, and this is width, and this is height. So height, width and length, so all is there. So this is called three-dimensional picture. So angles, we know that angle in a clockwise direction, a whole circle creates this 350 and then 360. So a whole circle creates a 360 degree either in clockwise direction or in anti-clockwise direction. So this is so half of it, this is called from here to here, half. If we take it to 0, and then this is 180 degree, and from this here to here we have this 180 degree. If we are taking 0 here, if we are taking 0 here, then we have this 180 degree, and from here to here we have 180 degree. So many directions. So here we have a 0, so that's why. So half of this circle is 2 pi or 180 degree, and quarter is 90 degree. So in this case, this is 180 degree and this is 90 degree. This is right angle, this is 90 degree, and this is less than 90 degree, so it's called acute angle. This is called right angle. If angle is more than 90 degree or less than 180 degree, it is called obtuse angle. If angle is more than 180 degree, then it is called reflex angles. So this is reflex angle. The other side is called acute angle, and this is called reflex angle. So here this is called reflex angle. So this is called reflex angle, and this is called obtuse angle. So the line that never meets are parallel to each other. So this is two parallel lines which will never meet at any point. These two lines are intersecting each other. So this is called perpendicular lines. And for each of these angles, say that whether it is acute, obtuse or reflex, A, B, C, and then we will see this details here, and D, E, F. And similarly for the question number 2, what sort of angle each of these sizes? You can notify these kind of angles. ABCD is a rectangle, which side is perpendicular to AB or which side parallel to DC. So let's start this 28.1 exercise, and for which we have this angle is basically acute angle, this is right angle, this is more than 90 degrees, so it is obtuse angle. So this is acute angle, this is reflex angle, this is reflex angle. What sort of angle each of this side is? 145 is obtuse angle, 86 acute angle, 350 reflex angle, 190 reflex angle, 120 obtuse angle, 226 reflex angle, 26 acute, and 90 degrees right angle. So if it is a rectangle, ABCD is a rectangle, which side is perpendicular to AB? This AB. So AC and BD is both perpendicular. This is also perpendicular and this is also perpendicular in a rectangle case. Parallel to DC, this parallel to DC is this AB or BA. So let's discuss the bearings. Bearings are used to describe a direction measured in degrees from north clockwise. From north side to clockwise direction, we measure the bearing and it shows the direction. Used especially in a shipping area, science or marine science or navy, all points of navy, people use this kind of bearings, angles. That's angle, but it always measured from the north side, so or in clockwise, made up of 3 digits. Bearings always choose with the 3 digits. So write down the bearing of these direction: due east, due south, due west, north and southeast. So we'll show this. write these angles as a bearing. So this becomes 024 and this is 101. Same, this is 003, and for the bearing of from this to A, B, C, D. So we'll write this. This bearing is 080 and this bearing is 120 degree, and this is add something this. So we'll show this. So bearing is it is used to describe a direction measured in north to clockwise direction and made up of 3 digits. So this is due east, so this north to this, so this 90 degree 090. Bearing is always shown with 3 digits. So due south is 180, so 180 degree, 3 digits are covering. Due west is this, so this is 270 degrees, so this is 270, and northeast is this is 45 degrees, so 045. Due south is 90 plus 45 is 135. And the B, to question number 2, write down these angles as a bearing. So 24 degrees is equal to 024, 101 is 101, 003 for the bearing of 0 to the point A, B, C, D. So this is 0800A. For angle B, we will add this 80 plus 40 is 120 degree. So for C, we will add this 120 plus 105 is 225 degree, and for D, we will add this 85, and this becomes 310 degree, and the remaining we will come to the north side. So the triangles. So the triangles is a 3-side shape. These are right angle triangles. So this is a 3-side shape, 1, 2, and 3. 1, 2, and 3 is a covered shape. Is a complete covered shape. Is a 3 sides. The covered shape is a right angle. Is a triangle. And here we have a 1 right angle, so that's why it's called right angle triangle. If we have 2 sides equal in a triangle, and then the corresponding angle will be same. So this is isosceles triangle. Here these 2 sides are equal, the corresponding angles are also equals. In this case, this is called isosceles triangle. If all sides are equal, and then all angles becomes equal. So in this case, we have this all 3 sides are equal, so all 3 angles are same. So it is called equilateral triangle. And scalene is a triangle that where no sides are equal and no angles are equal. So this is called scalene. And a quadrilateral, the quadrilateral have 4 side shape, and here we have 7 different types. This is called a square. All sides are equal and every 90 degree, and every angle is 90 degree. Here every angle is 90 degree, but 2 sides are equals, and these 2 opposite sides are equal. Here we have these 2 sides are equal, but these 2 sides are equal, but there is no 90 degree. Here in rhombus we have this all 3 sides, these 2 sides are equal and these 2 sides are equal. So all sides are equal, but there is no 90 degree. But here in this trapezium, these 2 sides are parallel and these 2 sides are non-parallel. In a kite, we have these 2 sides are equal and these 2 sides are equals. In a trapezium, we have this 2 sides are parallel and these 2 sides are isosceles. So this angle and this angle is equals. So this is isosceles trapezium. So for every shape we have discussed, we see that squares, all angles are 90 degree, lengths all equal, parallel, opposite sides are parallel, equal length, bisect at 90 degree, rectangle all 90 degree, opposite sides equal, opposite sides parallel. So this is the information for this rectangle, and equal lengths bisect but not at 90 degree. Parallelogram, opposite angles equal, opposite sides equal, opposite sides parallel, not equal, bisect but not at 90 degree. So not equal, bisect but not at 90 degree. Rhombus, opposite angles equals, all equals, opposite angles equals, all equals, opposite sides parallel, not equal, bisect at 90 degree, not equal and bisect at 90 degree. Trapezium can be different on one pair of sides parallel, nothing is special. Kite, one side of the opposite angle equals, 2 pair of the adjacent sides equal, none parallel, not equal, only one bisected by the other, they cross at 90 degree. So the bisections always cross at 90 degree. So isosceles trapezium, So two pairs of adjacent angles equals, one pair of opposite sides equal, one pair of opposite sides parallel, equal length, do not bisect or cross at 90 degree. So these are the information that we have used, and this is all shown in this diagram. So this information is there, and this has been tabulated here for the angles and sides and diagonals with respect to the angles, sides and diagonals. So this information is very important, and with the practice this can be memorized. With the proper application or the proper understanding of these diagrams, this information can be memorized, can be understood, so it become memorized. So polygon is a many side shapes. So here are some common one. Apart from the triangle and quadrilateral, you have met already. So the shapes, if the sides are 5, then it's called pentagon. If the sides are 6, then it becomes hexagon. If sides are more than 8, it is called octagon. If they're more than 10, it's called decagon. So this is when the sides of the polygon are the same length and angle of the polygons are all the same, it is called regular polygon. So this is a regular polygon because all sides are equal. Here this is all sides, hexagon, regular hexagon, because all sides are equals. This length of all sides are equal. Similarly with this pentagon, all sides are equal. So the side of the shape is continued outside the shape, and the angle made is called exterior angle. So every interior angle, there is always an exterior angle. So this is also important. So polygons, so we have learned all these things, and in this exercise we will solve this 28.3. So draw any pentagon, drop diagonal across the pentagon from each vertex and corner of the pentagon to another vertex. How many diagonals can you draw in the pentagon altogether? So we have solved this one, and similarly the other problems which quadrilateral have all four sides the same. So this is draw a pentagon across the pentagon from each vertex. So we have draw this, and we can see this from this line to this, and we have this from this point, we have this line and this, from here we have this line and this, and from here we have this line and this. So 5 diagonals as shown in figure. So this is 1, 2, 3, 4, and this is 5. So 5 diagonals are there. Which quadrilateral have all 4 angles of same? So the square and rectangle have all 90 degrees. Which quadrilateral have opposite sides the same but not all 4 sides the same? So that is rectangle and parallelogram. So these are the information. This is we are solving it. So a rectangle can be described as a special type of parallelogram. What else is true about a rectangle? All 4 angles are 90 degree, opposite sides parallel and the same length, diagonals same length. Diagonals is also same length. So if we use this rectangles, we can understand that the diagonals have equal length. If we draw this diagonal here and this diagonal here, the length of the diagonal will be same. Which quadrilateral have all sides, all 4 sides the same? Square and rhombus have the same sides, have same length. And which quadrilateral have opposite sides same but not 90 degree? That is parallelogram and rhombus. Parallelogram and rhombus. Rhombus is also some kind of parallelogram. So we can see this rhombus. This is rhombus, so it will never intersect. These 2 lines will never intersect. which quadrilateral have opposite with this parallelogram and rhombus? A rhombus can be described as a special type of parallelogram. Which else is true about a rhombus? Opposites angle equal, all sides equal length. Opposite angles equals, all sides equal length. Opposite sides parallel, diagonal bisect at 90 degrees. So this is the information which is relevant to the rhombus. So rhombus diagonals always intersect at 90 degree. Opposite sides parallel, it can be seen there. Opposite angles equals, it can be observed through the figure. All sides equal length, everybody knows, or we have already described it in the previous answer. Which quadrilateral have diagonal that crosses at 90 degree? Rhombus and squares. Squares diagonals always cross at 90 degree, and rhombus also cross at 90 degree, and also kite is also cross at 90 degree. Are diagonals. So if we draw the diagonal from the kite, we can see in any kite. So we have this kite. So if we draw this line here and this, it will at 90 degrees. So the diagonals crossing will be at 90 degree. So cuboid. So we have a solid space, and this is a three-dimensional shape, and we will discuss this topic in the next session.